So our first featured speaker, I'm really stoked to hear from. His name, as I mentioned earlier, is Boyu. He is at the University of Helsinki, and he's going to be talking to us about his LoRa-based approach to federated fine-tuning. And so over to Boyu. I'm really stoked to hear your talk.
Yeah, thanks, Nick. Thanks for having me. I'm going to share my screen. Is it good to look?
Yeah, it looks good to me.
Okay, cool. Okay. Hello, everyone. My name is Boyu, and I'm from University of Helsinki, and I'm here to present our work recently. It's just published in ACM Transaction on Internet Technology of last month, and the title is HeLoRA, LoRA-heterogeneous Federated Fine-tuning for Foundation Models. First, I have a short bio to introduce, and I'm a final year PhD student, which we call doctoral researchers at our university. And my supervisor is Professor Pan Hui. And for now, I focus on efficient and heterogeneous federated learning. And I also do some research about edge and pervasive computing. And for now, I have published papers on ECCV, IEEE, PERCOM, big data, and journals such as TMC, TOSN, and TOIT. I also serve as a reviewer for PERCOM, continuous 4 years, and IGCAI, TMC, and some journals about bio and other intersection areas such as GB, HI, and IoT journals, etc. So first, let's start. And I assume that everyone here is very familiar with what is FL. And we just to repeat them and as an introduction to what we are going to talk. First, FL is that we have one server, we have some clients, and the model is always initialized by the server. And the clients will conduct a local update with their private data to update the global model. And you can check here from the different colors, which means that the different colors, they are represented for different knowledge. And after the aggregation, they will be integrated to the global one. So they have contributed to the global one. But we should notice that the model here is always fixed because it's a universal one. It's initialized by the server and it's shared by all parties. However, in real-world settings, these clients might have varying resources, which means that they might have different processing ability to train models, such as this. Some devices, they might have like a very powerful resources with GPU-equipped server, but some of them, they might just purely resource constrained like a Raspberry Pi. So the problem will arise like several problems. One of them is structure issues, which means that the fast one is always need to wait for the slower one. And also the server needs to wait all of them because the conventional FL assume that we need to do the aggregation once all the updates are collected. And so this is also lead to another problem like resource wastage or etc. And moreover, with the increasing model size, like nowadays the LLM, the very big foundation models, we need to do very heavy communication overhead because FL always assume that we need to transfer the model parameters or gradients. So this is another problem. And yeah, let's see what happened. This left is the left one is the traditional weight averaging. And what we want is that for this Raspberry Pi, we want to give them a small model. And for a laptop with more resources, we want to have it have like a full model or a bigger model. But the problem that is here, the first one is that how can we aggregate models with different structures? It's very apparent to see that they have different model structures. And for the conventional, we just do the vanilla element-wise averaging. But now, since the parameter shapes are totally different, we can do that. So the first question is how can we aggregate? And the second question is that can we use light structures to achieve model parameter exchange so that we do not need to transfer the heavy parameter tables. And let's move to the preliminaries. And first, we want to introduce the rank for people who are not very familiar with that. So rank means that low rank adaptation. So this is a parameter efficient fine tuning method, which only use the LoRa parameters, which only updates LoRa parameters, while the original model, like this blue one, they are keeping frozen. So by this way, we can just reduce trainable parameters significantly because we can just train these two matrix A and B. We can keep this frozen, and by introduce these very key parameters rank R, we can slightly adjust this model complexities. For example, if we give R a very small one like 4, it might be a light model. But if we give R a very big one, it's also can become very similar with the original one because it depends on the R. And so they can see the forward path become the original one is just a WOX. Now we can have this B and A. So we just keep this frozen and train the B and A. So this is LoRa. And for another preliminary is the problem definition. So since we are aim to perform federated fine tuning across clans with heterogeneous LoRa modules based on the resource of devices, which means that, as I mentioned, for example, maybe for GPU equipped servers, we can give the R very big, like a 2, 5, 6. And for a Raspberry Pi, we can just give them 4. So since that, we will have this heterogeneous LoRa models. And we want to have this global model to update like this. So NK is here, is the amount of data of each client, and N is the total. This is very similar with the traditional Fed average one, but we can see the WKR is different. They have different shapes. So this is a challenge here because R is different. So this is the what we introduce our method here. Our method is HeLoRa, and we propose two variants. The first one is called HeLoRa pad, which is a very straightforward idea because you can see from the name, we just pad them. And you can check from here, there's a client, assume we have client 1 and client M. And client 1 has the rank is R1 and client M is RM. But they are both less than the global one. The global one is like a full model, but this is like a truncated model to tailor for their resource constraint. And we just padding them to make them align with the R global so that we can send them to the server side to do the element-wise averaging because they have the same parameter shapes now. And what we are padding is depending on, we propose this context-based padding function, which will be introduced very soon. And after they do the element-wise averaging, we will truncate them to their original shapes. And like this, we will give them R1, RM, and they send back to the client side. So this way, we can achieve aggregations even if they have different original models. So the context-based padding is also very interesting. So you can check, we can just apply different functions to them. The first one is the maximum. So if we want to pad a row like this, if we want to pad a row, so the P is always calculated by this column. Like if we want to have the maximum, the maximum of this column, then we will pad as a P for that. So if we want to pad a column, we want to have the maximum of this row to get this P. So this is our strategy. And also there's another strategy called adjacent function. So this is also very easy. We just copy and paste like this. If we conduct this strategy, we just copy this column to this, and we just copy this row to this. So this is a very straightforward way, but we will illustrate them in the experiment later. It works very well compared to just do the zero padding. And next is the rank-based adaptive aggregation. So there's an empirical evidence that shows the model with a larger R generally achieve better performance to a certain limit in LoRa because we have more model parameters, we can have the more training, training well. But based on these insights, we will assign larger weights to models with higher R values like this. So instead of just consider the amount of data, we introduce another dimension, which is R here. So with this design, the model with more parameters, they will make a larger contribute to the global model. And the models with few parameters, for example, the Raspberry Pi, they might just have the R equals to 4. And if they have a bad or not very well training result, they will also minimize the potential harm to the global model because the R is very small. But this will still providing valuable contribution by this different rounds of training. So this is the path. But let's check the pros and cons. So the pros is that this variant, this HeLoRA path is very easy to conduct and it's very easy to compute. But the cons is that, with the padding, the structure modification happens. Because for now, pre-release R equal to 4, now they maybe R equal to 128 sometimes. So this might destroy the original learned stuff. So this is the cons. So the question is that can we achieve model aggregations without modifying the model structures? So this is the another variant we propose called HeLoRA KD. So let's have a very short recap of what is knowledge distillation. So knowledge distillation basically is just there's a big model called teacher model, and there's a small model called student model. And the teacher model will do like will output logics, and the student model also have the logics. They will compare to each other using a KL divergence loss to minimize this loss so that the student can be performed as good as the teacher models, but they have much less parameters. So follow this idea, we propose HeLoRA KD. So you can check from this figure, instead of adjusting the rank values, we just keep them unchanged. This is R1, the server side is also R1, RM. But we propose a mutual distillation process so that this knowledge can be sharing with this process. So instead of performing element-wise parameter averaging, the knowledge are sharing with this process. I will give the details soon. So let's check. So we call this a deep mutual learning based aggregation. So let's assume that we have M LoRa modules. So this procedure on the server side begin with performing forward pass with public data sets, so that each model will generate their logics, right? Because they are different structures. And we will first calculate the conscious, like here. The conscious is calculated very similar with the idea of the rank-based adaptive aggregation we mentioned, in HeLoRA path. So we also consider the R value here. So the loss function becomes here. And so this is also a very similar idea with the traditional knowledge distillation, but we apply it here. So the first item is the traditional cross entropy loss, and we introduce this KL divergence loss to make each client, they will have to minimize the distance between the conscious, because the conscious, they have all the knowledge from the different clans. And now we want to each clan to as close as to this conscious. So in this way, after the multiple round of training, each clans, they will have the knowledge globally. They will have other knowledge. But instead, we do not modify the model structures. So this is very interesting. And LE loss just as a cross entropy loss. And we also use a beta, a hyperparameter to control how much knowledge they will learn from others. Yeah, so this is a fine-tuning problem, fine-tuning parameters we will mention in the experiment. And so that's basically all the design. And for the experiments, we have like two tasks. One is image classification task. Another one is NLP. We use the very traditional one, CFR 110 and MDB and SS22. For the baselines, we select the traditional Fed average, and for Fed IT and SLoRA, these are two methods that equipped with LoRA, but the more or less is the vanilla combination with LoRA with the Fed average stuff. So this is we call that model homogeneous approaches because they are not allowed, they have different model structures. And for the model heterogeneous approaches, we select HeLoRA. This is a very similar work with us, but as I mentioned, this is just a zero padding one compared to our HeLoRA pad. And this four are another method that allowed heterogeneous model. So for the models, we use the vision transformer and distilled bird. They are also they all downloaded from the Hugging Face. And for the settings, we select 20 clans with their ranks. This is LoRa rank, equally assigned with these four values. Let's check the performance. So if we check this performance on 4 datasets, we can find that both the HeLoRa pad and KD, they outperform the rest baselines. And especially the KD is also performed slightly better than the HeLoRa pad. And you can also observe the HeLoRa pad works continuously better than the HeLoRa, which is just a zero padding. So, and also compared to the standalone, our results is also very close to the standalone, which means that we combine LoRa and our method can achieve really good results. And for the rest experiment, we changed different heterogeneity levels because previously we just considered these four, but now we give them to minimize the to simulate the real world. We give them these different value ranks from these different distributions, and we sample them and we find them. We give them the results here, and we also find that the HeLoRa KD outperform the rest. So this is interesting. And an interesting observation is also can be followed here. So if you check the uniform and the normal one, the uniform is more sparse and the normal is more centralized. But our method, you can see from here, compared to HeLoRa, it has better performance in this uniform one than the normal one. This is because the knowledge distillation one can give different knowledge sharing from different rank values. So if R is like very small one is 10 and this is 100, they can also give the 100 knowledge to the 10 one. So even in these very sparse distributions, HeLoRa KD works very well compared to this normal one. And another one is we also try apply LoRa different layers. This is the QKV for the transformer-based model. And you can check if we apply the QKV or we apply QKV, this is a better performance than just a standalone for QKV single. And you can check from here, we also have a very small training parameters compared to the full fine-tuning. And yeah, we also check the different padding functions for the HeLoRa pad. As I mentioned, there are max, minimum, and adjacent. And compared to the 0, the 0 is the baseline HeLoRa. And you can check, actually, the adjacent one, just the copy and paste can achieve a much better performance, not much better, but slightly better than the other padding strategies. That just implies that the model parameters is also equip some knowledge. So if you want to give them just a zero padding, they will have some chaos after the aggregation. So it's better to just copy and paste to maintain their original knowledge. And for the other is that the hyperparameters analyze for the beta. The beta is how much knowledge sharing from others can involved. So you can check from here that different datasets actually have different optimal values. The CFR10 has the 0.6, but IMDb is just a half. This is because that for the datasets, for more complex datasets, the knowledge they require is more. They need more knowledge from others because it's more complex. So it need more knowledge from here, which means the beta need to be bigger. So this is this one. And we'll also verify the different client number from 20 to 60. You can check from this figure that our HeLoRa KD always is more or less remain the same. But for HeLoRa pad, it's just the drops because maybe if the heterogeneity is much bigger, the padding will not work as much well. And also for the rest one, they works much lower than us. So this is this, and we also do some ablation study for the rank-based adaptive aggregations, which is the R value. So you can that with or without it. With it, it has a slightly better performance than without that. So yeah, and also do some two case studies. So the rest, the above one is just the transformer model. So we to check if our method can work on non-transform models. So we try the ResNet 50, and it also works well because LoRa can be directly applied to convolutional layers. So this also applied to our work. And another case study is that we check the non-classification task, which we use the squad datasets, and it also works well. The only need to modification is that we need to change the class-based logics to the position-based logics. So we just need to slightly adjust our loss function. And that's all. So the conclusion is that we propose HeLoRa. It is a novel federated fine-tuning framework designed to address system heterogeneity challenge. And we also have two variants. One is the HeLoRa pad and the HeLoRa KD. They both employ different strategies to achieve LoRa heterogeneous aggregations. And an extensive experiment shows that HeLoRa perform well in NLP and the CV tasks. And for the future work, I think first we want to explore more efficient padding strategies to minimize structure changes. For example, if the heterogeneity is very serious, how can we handle that? And the next is try to perform KD without the public datasets. This is the one of the limitation of our method because we need to rely on a public dataset. And the third one is that we want to extend our evaluation to a broader range of foundation models because for now we just use the vision transformer and some DistillBERT one. It's quite small compared to the nowadays one. So we want to check them like the GPT and also the Llama if it can work with our method, our framework. So yeah, that's all. Thank you. So if you want to check more, you can have me on this QR code. Thank you.
Thank you. That was great. So then anyone who's watching right now, feel free to pose any questions right now, and we can get to you. I see someone has posed a question. I'll just ask. I'll ask this one on behalf of the person, but feel free other people just to raise your hand, or I've also got the different channels open so I can hopefully see questions as they come through on X or YouTube or so forth. But so our first question was, thanks for the insightful talk. Is it possible for you to share the slides? So
Sure.
yeah, okay. I guess
How should I share the slides? May I
I think
ask?
they could just email you here, or if they have difficulty finding you, they could mail me, and I can get them in touch with you.
Okay,
That's
just
fine.
feel free to email me. I'll send you the copy.
Yeah, great, great. We have another question here from Adam. I'm just going to enable him to talk. So Adam, your microphone is going to just come online, and so you can ask your question.
Perfect. Can you hear me?
Yes.
Yep, we can hear you.
Awesome. Thank you for a great presentation, Boyu. It was really, really interesting. I was just wondering, you dealt with the problem of resource heterogeneity between the clients. Did any of your evaluations touch on data heterogeneity, so label shift or feature shift among the clients?
This we consider that because for this results you can check. We just follow the traditional non-ID distribution here with this distribution with 0.1. This is a very common setting for federated learning papers, I assume. And for this paper, our main focus is not for the data heterogeneity. We focus on the resource, or we call that system heterogeneity. So if you want to check the data heterogeneity, I think maybe and this is one of the, I think, future direction to combine this framework with the data heterogeneity. I think it's a more interesting topic. But for now, we just use the traditional one to follow. So we do not have any very special design for that. Yeah.
Cool, fair enough. I'll see if anyone else wants to ask a question. Yeah, I guess not. I'll just ask a question here. I was wondering, is there any backstory to how you came up with this idea? I'm always curious about how people kind of come up with their ideas. So were you thinking about how do you do fine tuning, or were you interested in LoRa and how it could be used into federated learning, or what was the impetus for you inventing this?
Well, I think I have some papers accepted about model heterogeneity previously, and before I doing research about federated learning, I also do some, I can mention the edge computing and pervasive computing. So I'm very familiar with the hardware. So we always do the Raspberry Pi and some NVIDIA development kit. So I wonder. Yeah, so I just know these are heterogeneous. So if we want to apply federated learning on them, it might have problem because they have different processing ability.
Makes sense.
Yeah.
Yeah, cool. Great. Well, then I think we should move on just in the interest of time as well. So thank you for the great talk. Amazing stuff.
Thank you.
Yeah, thank you again.